So in this session, we covered the topic on first principle modeling. We take the specific example of chlorination of pool. In this problem, the two variables are changing at the same time, meaning the two output variables. So we'll be considering the relation between what happens when there is a change in this inlet flow, what will happen to this chlorine concentration here. Okay? So you see that if this level is changed, there will be change in this flow rate is changed, there is a change in the level here, also the chlorine concentration will change. Now they will be related, those two variables will be related. So now you need to establish all this relation between this input and the set of output variables. So the model object will be to find a model between C2 and F2I. Now again, going back to the overall control problem here for this pool case, we may want to find relation between C2 and F2I because we have three variables in this process: the level, the temperature and the concentration. The temperature can be directly manipulated, maintained by manipulating this heater power, and then the chlorine concentration can be maintained maybe by manipulating this flow inlet here, and the level can be maintained by manipulating this flow rate. Okay? So when we change this flow rate here, that will affect not only the level, it will also affect the concentration of chlorine. So we need to find that relation as well. Okay? So to find this, let's look at what's the link between these variables. So step 2 will be to gather process knowledge and information, and we see that this F2I will reveal C2, but also this F2I will affect H2. So in this H2 will have an effect on C2. So you see that we will have not only one direct relation, there will be more than one relation to relate these variables. Okay? Now when we have this objective set and the information obtained, we now look at the step 3, which is the development of the model equations. Now if we look at this conservation of mass, the overall mass balance for this case, now for the time being, we will only focus on pool 2. We see that we can do the same for pool 1, but for this specific case, we are looking at pool 2 because that's what we are interested in. Also, you can think about when there are other variables in place. For example, the heater power. The heat energy has nothing to do with the chlorine concentration for this case. Okay? So you see that when one particular variable doesn't have any effect, we can totally take that out of this domain of model identification. Okay? So write down the conservation of mass principle for this pool 2. You can simply have this term is the accumulation term. We have done it many times. In, out. Okay? So rate of accumulation of mass in pool 2 equals rate of mass in these two terms. There are two streams coming here, and then you have the outlet stream there. So you get the overall mass balance, that one. Now let's look at the component balance. So we have two components here, chlorine and the water. We know that when you have two components, if you write down the overall mass balance, you can write only one component balance equation, because if you write two component balance equation, adding those two would give you the mass balance overall mass balance equation. So we have one equation to write here. So the component balance equation can be again accumulation of definitely I, any component. So for our case, it's chlorine. And it will be I in I out, generation, consumption. So you see that for this case we don't have any reaction, so this term will be 0 as well. So we have accumulation equals in minus out. Now if we write down this equation here, rate of accumulation, we have the mass to be rho V2 if the chlorine concentration is C2 here it's C1O, here it's C2I, we can consider this to be 0, this one will be C2. So rho V2 C2, that gives the mass of chlorine, its rate of change with time gives you the in will be, we have two streams coming in, so rho F1 naught C1 plus rho F2I C2I minus rho F2O C2. So you have this balance here. So now the rho terms get cancelled, and if assume this to be 0, we can simplify it further to be Now here you see that the A2 is constant taken out, but H2 is not constant because there is a term dH2 over dt. So you see that the H2, C2 both are variable with time, so we cannot take any one of those out of this equation. Now let's take a look at this, what we can do with this term. The left hand side of this term equals dt. So we can write it as this. There are two variables here, so we'll have A2 H2 d C2 over dt plus A2 C2 d H2 over dt. So that's the derivative of two variables. So we have, if you have d dx yz, it will be y d dz over dx plus z dy over dx. Okay. So we have this equation now. Now from this part, we can have, say, together we can write, so this term remains A2 H2 dC2 over dt plus, if I change this part with, we have C2 times A2 dH2 over dt becomes F10 plus F20 minus F2 out. So we have F10, F2y, F2O, C2. So that's our left hand side here. So this part we just got out of this entire things here using this term. Now equating that with the other part then, so if you just simply take now this one, the left hand side, this is equals F1 naught C1 minus F2 naught C2. Okay. So you have this now, this equation, we have expressed the left hand side using this term, the right hand side put it here, we get this our overall our component balance equation there. So you see that in this term we have this and this to be the same, so that will be cancelled out. So we'll get, if we rewrite this equation, we'll have A2 H2 dCt C2 over dt will be, we have F1 naught C2 and F1 naught C1, we'll have F1 naught C1 minus C2. These two cancels out, so we'll have only this term. C2. So this term was plus on the left side, so I took on the right side, so it becomes minus. So we have this equation here. We see that we have one relation here and the other relation over there. Now going back to these links here, so we have this equation, relation between F2i and H2 captured by this equation, and we have this relation F2i and then its link with H2 is captured by this relation. You see that this relation, the relation between C2 and F2i is there, but again the other terms H2, C2, these are also there. So although this is not in a standard form, we see that this is the equation we can further just rearrange to get the equation in its standard form. Now again, this example just simply describes when the two variables are changing because of the change in one input variable. Now we see that there will be a list of activities involved when you have these terms together, how to handle those things, because we have this output here, this input here in the same term. So we'll have to manage those terms and simplify those to get in their required form.